Hi, I'm Katie. For my Metis investigation, I'm going to talk about computer vision. I'll start with a general introduction to vision and briefly go through the history. I'll also show you a couple of beginner-friendly tools and finish with the future of computer vision. So the first chapter, what is vision? Scientists think that the earliest version of eye was formed in single-celled organisms. Like you see here, they have these red dots called eye spots that are made of photoreceptor proteins and are sensitive to light. This is not sufficient for vision, of course, as they could not distinguish shapes, colors, or determine the direction of light. But over time, the unicellular creature would evolve and the eye spot would evolve along with it. First, a depression would form around the light-sensitive spot, creating a pit so that it can detect roughly the direction of the light. And the pit's opening becomes smaller and smaller, and eventually it will be like a pinhole camera. So sensing light direction is much sharper, and from there, a retina would develop. And this is the eye we have today, which is the most complex organ in our body, other than the brain. It's amazing that how in the beginning it was just a simple light sensitive structure, but now we can detect accurately where the light is coming from. We can focus to see something far away, or we can focus to see something close up. We can see different shapes and colors and many more. But all these that I just mentioned are just collecting signals. What happens afterwards is more important. Visual processing is the term referred to the brain's ability to use and interpret visual information that we obtain through our eyes. So basically, our brain takes all of these signals and processes them to give us vision. Chapter 2, the history. We talked about the ancient history of vision. Now we can talk about more recent events. In 1956, the term artificial intelligence was first used in a conference. Back then, scientists were very optimistic about AI and thought it could be realized soon. And in 1959, there was a big discovery in neurophysiology. The vision is hierarchical. It means that when you see an object, for example, this building here, your simple cells in charge of low-level visual processing will see the edges or determine the orientations of the edges. And then the complex cells that see colors, basic 2D shapes. And lastly, the even more complex cells will perform the high-level visual processing, like recognizing complex features or integrating the information. So much of what we know today about visual perception comes from the research done in 1950s and 60s. And it is also the foundation of computer vision. Based on the knowledge of vision hierarchy, computer scientists want to recreate this structure in a digital form as a stepping stone to realizing artificial intelligence. So the plan is we have the image as the sensory input, and then it will go through different levels of processing, just like how our vision works. Essentially, an image is a projection of the 3D world onto a 2D plan. There are pixels, color channels, etc. For the low-level processing, it can be image manipulation, like resize, adjust exposure or color. And for mid-level, the image may have some sort of interaction with the physical world, like LiDAR. You can measure the actual distance of an object. Or like multi-view stereo, you can reconstruct a 3D object based on images taken from different angles. For high level, the algorithms would make sense of the visual content. Like we can teach the computer, this is a cat and this is a puppy, so it can perform classification or detect where the objects are. Or in an opposite direction, from semantics, it can generate images like GAN or deepfake. Now, it's very easy for us to talk about these algorithms today, but back then, the scientists didn't know how challenging it would be. So going back, the first computer vision project was actually a summer project for a first-year undergrad at MIT. The idea was to connect a camera to a computer and get the computer to describe what it saw. But of course, there was no success. Sadly, in the 70s, the AI winter came because the scientists were too optimistic in the beginning and raised the public expectation too high, but failed to live up to it. So the funding dried up. Things were slow, not much was going on. However, in the late 80s to 90s, the rudimentary neural networks were developed. And in 2001, face detection was proposed by Viola and Jones. Even though it's from 20 years ago, it's still pretty useful today. And now talk about the tools. We can actually use this face detection in OpenCV, the open source computer vision, which is a library mainly for real-time computer vision. You can use it for image processing, and it supports deep learning framework as well. The documentation and GitHub are really good. You can find a lot of information there. And for the face detection algorithm, there are two main features, hard features and cascade classifiers. Here are two examples of hard features. One is that the eye region is often darker than the nose and cheeks. The second is that the two eyes are darker than the nose bridge. There could be like hundreds or thousands of features. What you can do is group these features into different stages of classifiers and apply them one by one from simple to complex. If a window of an image fails at the first stage, discard it. We don't have to consider the remaining features on it. If it passes, apply the second stage of features and so on. So the window that passes all the stages is then detected as a face. In an image, most of the region is not a face. So by using this cascade approach, you only need to run the complex classifier on a small amount of windows. So that will save you a lot of time. When you install OpenCV, it comes with the pre-trained classifiers in the data folder. You can access your webcam and draw a rectangle around the detected face. For example, like this. This is Siobhan. You can also prepare your own data set to train for face recognition. And for fun, I tried it with my 3 cats and it works. Now let's go back to our timeline for a bit. Before I talk about the second tool, the real breakthrough in computer vision happened in 2012, coming from a deep neural network, AlexNet. It was the winner of a visual recognition challenge that year. But we should keep in mind that the convolution network did not happen overnight. Earlier in the 90s, there was already the LeNet proposed by LeCun. Also, the success of having machine learn and predict relies not only on the algorithms itself. More data and better computation hardware are also the key ingredients. So in the years following AlexNet, error rates at the challenge fell to a few percent. And now there are many other deeper networks like VGG, ResNet, etc. Basically, deep neural networks are the golden standard for image recognition. What I want to show you today is DarkNet. It has features like ImageNet classification, RNNs, but the most famous one is YOLO. It stands for You Only Look Once, which is an excellent real-time object detector. It is very easy to use and already trained with 80 classes. And to use the pre-trained model for detection, you only need to go through 3 steps. First, on Google Colab, clone the DarkNet repo and make sure you can run OpenCV. Second, download the pre-trained weights, and then you can run the detector. Here you can see in our example, there's a dog, a person, and a horse that are detected. You can also train your own detector with 2 more steps. That is to prepare the data set and some config files for training. The first one requires a lot more work because you need to prepare both the images and the labels. An easy way is to use Google's Open Images data set. For example, you can search for hedgehog. Then you can get all these images with hedgehog masked and labeled. However, if you can't find what you want in the data set, like cat eye, then you'll have to manually annotate all the images. But as long as you have the data set ready, it's very straightforward. With the label data set, you can just run some Python scripts to generate the required config files, like these. And again, download the pre-trained weights for the convolutional layers to save time for training. And then you just have to wait for a few hours for the detector to be trained. In my case, I was looking to detect cat eyes, and it worked really well. So what's next? We see that yellow is easy to use and you can train with customized data set, but labeling the image manually, especially massive amount of images, is still the bottleneck. As Kun pointed out, it is impossible to label everything in the world, and sometimes there's simply not enough data. So the way to go is self-supervised learning, where the algorithm doesn't rely on label data sets to train anymore. Instead, they learn directly from the data. Self-supervised learning has great success in NLP, but in computer vision, it's a lot trickier. However, 2 weeks ago, Facebook announced that they used 1 billion Instagram photos to train its self-supervised learning algorithm, SEER. They claim that SEER outperformed the most advanced state-of-the-art self-supervised systems, also outperformed state-of-the-art supervised models on downstream tasks, including object detection, segmentation, and image classification. So if you're interested in the details, you can read their blog or their paper on archive. And that is all from me. Thank you.